My dear students, welcome to my whiteboard program. Today we have to discuss class 10 science chapter 4 carbon and its compounds first part. So today we have to discuss the following main points, that is atomic number, electronic configuration, availability of carbon and its compounds, then properties of carbon compound, then why does carbon make covalent bond, then how are covalent molecules are formed like hydrogen molecule, then oxygen molecule, then ammonia molecule, then your methane molecule. So today these main points we have to discuss. Let us come to first point. What is the we have to discuss today what carbon and compounds. What is carbon? Carbon is an element. Its atomic number is 6. So electronic configuration is 2, 4. So when atomic number is 6, then first orbit 2 electron will be there, that is called the k orbit. Then second orbit, the what is remaining, 6 minus 2 equal to 4. That 4 electron will be in the outermost orbit, that is called the L orbit. So carbon has 2 orbit, one is k orbit, another is L orbit. In k orbit it is well packed, that is 2 electron, and outermost orbit is L orbit, where remaining 4 electrons are there. So these 4 electrons are known as valence electron. So carbon has tetravalency. So we'll talk afterward what is valency and valence electron. Let us come. Valence electron means the outermost electrons. If this is carbon, it has 2 orbit k and L. K is already occupied, that is 2 electron, and L orbit there 8 electron must be there, but remaining are 4 electron. So 8 minus 4, then 4 electrons are left to make it 8. So 4 is known as the valency and 4 is known as the valence electron. So this is the carbon's unique property. Its valency is equal to its valence electron. So it is called the tetravalency, means 4 valency or 4 valence electron. So this is called the electronic configuration. The distribution of the electron in the different orbit is known as the electronic configuration. So its electronic configuration is 2, 4. Atomic number is 6. It is placed in the periodic table in the metallic part. Right hand side of the periodic table it is placed because it is the non-metal. So non-metallic part it is placed. Now we have to come to the properties and availability. Let us see. The carbon is available in solid form as well as gas form. In the earth crust, in the soil, in the earth crust, it is present in the mineral form, carbonate form. So that is in the solid form like calcium carbonate, sodium carbonate, etc. carbonate form, which is 0.02%. So it is available in the solid form, that is carbonate form, in the earth crust 0.02%, and in the atmosphere, in the gaseous form, carbon dioxide form, it is 0.03%. So this is the availability. In the atmosphere it is present 0.03%, and in the earth crust, in the solid form, it is mineral form, it is present 0.02%. This is called the availability of carbon. Then we will come to the properties of carbon compound. So carbon, we know carbon is non-metal and its valence is 4. So it always make the compound with others by sharing the electron, and by sharing the electron the compound which is formed known as the covalent compound. So carbon always make covalent compound. Let us see what are the characteristic properties of covalent compound which is same as the properties of the carbon compound. So carbon compound property is equal to the covalent compound property. So covalent compound property, we know it is made of, it is formed by the sharing the electron. Its boiling and melting point is less, means low melting and boiling point, because by sharing the inter attraction force is very less. So it's when it is heated with low temperature, it is broken. The bond is broken, so compound is broken. So that's why it is low melting and boiling point. Again, it is soluble, not soluble in the water, but soluble in the inorganic compounds. And it is the poor conductor of electricity. Generally, covalent compounds are poor conductor of electricity, whereas ionic compounds are good conductor of electricity. This is the various properties of the covalent compound or the various properties of the carbon compound, because carbon compound is also covalent compound. Let us come. Why does carbon make covalent compound? So we know there are two type of compounds are there which are formed by the two type of bonds. Some compounds are formed by the covalent bond, so that is covalent compound. Some compounds are formed by the ionic bond, they are called the ionic compound. But carbon generally form the covalent compound. Why carbon makes covalent compound? Let us discuss. Because I have told you the electronic configuration of carbon is 2, 4. So first orbit 2, then last orbit is 4. Here it is called the tetravalency. So its valence is 4. So to make 8 electron or 8 outermost orbit 8, it need 4 electron to lose. If it will lose the 4 electron from outermost orbit, then only one orbit will be left, that is called the k orbit, and that is already a field, that is a 2 electron. So any element or any atom having only one orbit, and if it occupy with the 2 electron, then that is filled, like the helium. Helium has 2 electron and that is already packed in the first orbit. So helium is stable, inert. So if carbon will lose all these 4 electron from the outside, then its configuration will be only 2, which is the configuration of the helium. Then it will be stable. So it can lose the 4 electron to make itself helium configuration. Or if it does not leave, so 4 electron it has already, then it can take also 4 extra electron from outside to make itself 8. So that is argon neon electronic configuration. So if it will get 8 electron, then it will be inert also. So it has the capacity, it can take 4 electron to make the octet, or it can leave electron to make the helium configuration. But the surprise thing is that carbon neither take the electron nor give the electron. So it cannot go for the ionic compound, because ionic compound is the compound which is formed by donating electron or receiving electron. So carbon, but here does not leave the electron or does not receive the electron, so it cannot do the ionic compound. But why it does not leave, why it does not gain? Let us see. I have given two reasons. Why it choose only sharing the electron, not gaining the electron, not losing the electron. So it does not lose the electron, it does not lose, it cannot lose the 4 electron to make its 2, because to lose the electron it need more energy to lose, because carbon, as carbon is very small atom, its radius is very small, nuclear charge of the carbon is very strong. So it just bind the 4 electron in the outermost shell with latest energy. But when it has to leave this 4 electron, the nuclear charge has to be lost. So more energy is required to lose it. So then if the more nuclear energy will be lost, then the atom may not be stable. So it does not want to lose the energy. That's why it cannot lose the electron. Second one, why it cannot gain also? It does not gain electron as it becomes unstable, because with only 6 proton it will be difficult to hold 10 electron. You see, once again I am showing here, that is this is the carbon atom, this is first cell 2 electron, then next cell 4 electron, 2 plus 4 is equal to 6, that is, so inside the carbon atom there is a nucleus, and inside the nucleus there is 2 things are there, one is proton, one is neutron. And how many electrons are there in the carbon? that number of proton is present inside the nucleus. So inside the nucleus, how many number of proton is present? How many number of electrons are there in total? So 1, 2, 3, 4, 5, 6. 6 electrons are there. That's why its atomic number is equal to 6. So what is the atomic number? That is the number of electron, that is the number of proton. So that's why 6 proton will be there inside the nucleus. Are you clear? Now we have to see, then if it will gain more electron, 4 electron outside, then total electron will be 10. Now its electron number will be 10, but proton number will remain 6. So with 6 proton, it is very difficult to hold the 10 electron as it becomes unstable, because atom always remain electrical neutral. Number of proton always remain equal to number of proton. Number of negative charge is equal to number of positive charge. That's why atom is electrical neutral. But when it will gain more electron, that is 4 more electron, then its electron will be 10, but proton will remain 6, which is very difficult to stable the carbon atom. So it cannot also gain the electron, it cannot lose the electron. So third option is what? It has to share the electron. When it share the electron, it makes the covalent bond, and by making covalent bond, it always make covalent compound with the other element. That's why carbon atom always make, carbon element always make covalent bond, because it shares the electron. It cannot take the electron, it cannot lose the electron, because reason I have given here. Okay. Next we will come to the how are covalent molecules are formed. Suppose covalent, what is? The sharing the electron. When any bond is formed by sharing the electron, then what happens? The bond is formed is known as the covalent bond. So let us see in this process how the molecules, how the compounds are formed. Let us see how the covalent molecules are formed. For example, all the non-metal element, maximum non-metal element, they make the covalent compound. But the molecules are formed, some elements are formed available in the nature in the nuclear, that is a molecular form. So like hydrogen never present H, it is present in the form of H2, that is called the molecular form. Hydrogen never available in the nature in the atomic form, H2 form. Chlorine is available in the Cl2 form. Oxygen is available in the O2 form, not in the O form. So they are called the diatomic molecule. And here they are called the homodiatomic molecule. Homo means similar type of element, atoms are combined to make the molecule. Here hydrogen, let us see first example. So formation of hydrogen molecule, that is H2. How H2 is formed? Because two hydrogen atom combine to form one molecule of hydrogen. This is called the homodiatomic molecule. Homo means same element, that is hydrogen and hydrogen. They combine to form. Diatomic means two atoms of hydrogen make one molecule, diatomic molecule. So let us see how hydrogen is formed. I have drawn here, and also I will demo here also, you can understand better. First let me to explain about how the hydrogen molecule is formed, how it is formed by the covalent compound. You see, hydrogen and hydrogen atomic number is what? 1. Its number of proton is how much? 1. Its number of electron is how much? 1. So but it need any atom, they have to make either first orbit, that is the last orbit. Means if it has one orbit, then it must have 2 electron to make itself stable. Or if it is more than one orbit, then it must have to make 8 electron in the outermost orbit to make itself stable. All the atoms that try to get the octet stage, means make 8 electron in the outermost orbit. So here hydrogen, that is, if hydrogen is one element, then there will be only one orbit will be there, that will be k orbit. In the k orbit only one electron is there, but it should have 2 electron to make it stable, but it has 1, so it is unstable. So as it will be remain unstable, it will try to make it stable, and it will be reactive, and it will search one more electron. So that's why hydrogen, again it will see another hydrogen who has also one electron. So they will decide to share one electron to each other in the borderline. So now hydrogen is sharing one electron here, another hydrogen is sharing another electron here, and they are making the boundary with this shared paired electron. So they are now stable because this hydrogen now it's within its periphery, so there will be two electron. So now hydrogen is stable. This hydrogen has also in its periphery two electrons, so it is stable. But they will make the bond relationship. That relationship is known as the covalent compound. So as two electrons are shared, only one bond will be formed because one bond is formed with two electrons. So here one electron is shared, another electron is shared here. So one bond is formed. So H single bond H, H single bond H, and how many hydrogen are participating here? Two hydrogen. That's why H2 is written. So this H2 is known as the molecule. Are you clear? So let us say I am just 1 second I am giving demo. Now you see hydrogen. Hydrogen atomic number how much? 1. And its electronic configuration will be 1. That means it has only one orbit. Another hydrogen is there, its atomic number also 1. So atomic number is also 1. It has one electron also. Now when this hydrogen will, but it need one more two, at least it will need the two electron to make its outermost orbit. So it is very sad. It is very sad, you can see it is very sad because it has only one electron. Now he is roaming here and there to collect one more electron, but no one is giving one electron. But another hydrogen is coming also, it has also one electron. Now it is also very sad when it is moving. So when this hydrogen is passing this hydrogen, asking what happens to you, are so very sad. So he said that you see I have only one electron, I need one more electron, but I am not getting. So he says also, hey, I have also same condition. I am also having one electron and I am not getting one electron, I need two electron. Then they decide, why we will not get one electron from anybody. We have to decide something. What decision they will take? They will take that I have to share this electron to here in the borderline. I will not give to you, and you also give the electron to here. So let us share. So this electron is coming here. This electron is coming here. Now the hydrogen is coming very near here. This hydrogen is coming downside also. Now this hydrogen makes its periphery about this two electron, and this hydrogen also make its periphery about this two electron. So now this hydrogen say I have two electron, so it is satisfied. This hydrogen also say I have also two electron, so I am satisfied. But they said that we cannot be now individually go anywhere. We have to go anywhere by a bond formation. That is bond formation. Wherever we have to go in this structure, we have to go. That is H single bond H, because one electron. So a pair of electron, that is one covalent bond. So they makes the covalent bond, that is single covalent bond between H and H. So now finally, how many atoms are there? Two atoms. So we write H2. These two indicate how many atoms are there. So that is one molecule of hydrogen. This is covalent molecule. Similarly, if we will go to the formation of oxygen. So let us see. I have given there formation of oxygen, how it is formed. Now oxygen, you see oxygen atomic number is how much? 8. Oxygen atomic number is 8. So its electronic configuration will be, in the K cell 2 electron will be there. Rest 8 minus 2 is equal to 6 electrons are left. That is in the L cell. This is K cell, this is L cell. Now it is oxygen. First orbit, that is 2 electron is occupied. The next orbit 6 electrons are occupied. 1, 2, 3, 4, 5, 6. But how many electrons it need to make itself octet? It need more 2 electron. So it need more 2 electron to make itself octet. But it is not getting. Another oxygen also coming. So its inner orbit is completed, and outer orbit also 1, 2, 3, 4, 5, 6. So it also need 2 electrons. So they will do, but now this say I will share 1 electron here. So 1 electron coming here. So now 1 electron, 1 bond. Again it says that 1 more electron I will give. So now 1 more electron, and it will also give 1 more electron. So another pair is coming. So another bond is formed. So now you see. So this electron is coming here. Now we have to rub it. Now this electron coming here, so it will change the position here. Here also this electron is not there, not there. So this electron coming here, this electron coming here, two electron coming here, this electron coming here, this electron coming here, two electron coming here. So two bonds are formed. Now this oxygen make this boundary with this one. This oxygen made this boundary with this. Let us see. This oxygen has how many electron outermost shell? You see, 1, 2, 3, 4, 5, 6, 7, 8. This oxygen says that I have 8 electrons, so it is satisfied. This oxygen also similarly 1, 2, 3, 4, 5, 6, 7, 8. There is no electron because they have already said. So 8 electrons. So now both are satisfied, but they will not be now individually, they cannot be free. They will make the bond. So O, and how many bonds are there? 2 bonds. 2 bonds O. So this is their structure. They will form how many oxygen are there? 2 oxygen there. So O2 molecule will be formed. In this way, oxygen makes the oxygen molecule. That is covalent bond, but it is double bond. There is single bond. Hydrogen case it is single bond. Why? Because hydrogen donate only 1 electron. Here double bond. Why? Because oxygen donate 2 electrons. According to their valency, how many number of electrons are required, that number of bond will be formed. So this is about the oxygen is over. Now similarly, nitrogen also N3, N2 also similarly, but it is triple bond because nitrogen atomic number is 7. So electronic configuration is 2, 5. So how many electrons are required to make here 8? 3 electrons. So this nitrogen will give 3 electrons and this nitrogen also give the 3 electrons. So 3 covalent bonds are there. So N triple bond, N will be formed, and H2 nitrogens are there, so N2 we have to write. Similarly, H2, O2, N2 all are diatomic molecule. So this is gone about the diatomic molecule. Let us come, that is homoatomic molecule. Today again we have to go to heteroatomic molecule, where the 2 different type of atoms are combined to make the molecule. For example, ammonia, NH3. Here two elements are there. One is nitrogen, another is hydrogen. 2 elements are participating. So it is heteroatomic, and this is heteroatomic molecule. Let us see how ammonia is formed. You can see I am shown here the atomic number of nitrogen. N means nitrogen is 2. Atomic number of nitrogen is 7. 7. Electronic configuration is 2, 5. First orbit 2, then 7 minus 2 is equal to 5. Atomic number of hydrogen is equal to 1. So it need how many electron? 3 more electron to make octet. So that is valence is 3. It need how many electron? 1 more electron to make 2 in the outermost orbit. So valence is 1. So it is valency 3. It is valency 1. It is very difficult to make their understanding between, because the covalent bond form when the valency match with each other, like hydrogen 1, oxygen 2, oxygen 2, but here nitrogen 3, but here nitrogen valence is 3, but that is called the hydrogen valence is 1. It is very difficult to make the covalent bond, but still then it make the covalent bond. Let us see. So when the bond is formed, only outermost orbit participate. Outermost orbit, how many electron in the nitrogen? Nitrogen outermost orbit is 2, 5. So 5 electrons are there. I have shown 1, 2, 3, 4, 5. These are the electron of outermost orbit of nitrogen. Now what happens? Suppose nitrogen 1, 2, 3, 4, 5 is there because it has a outermost orbit 5 electron. Now if it need how many? 3 required. Suppose one hydrogen is coming and saying that I need 1. Nitrogen need how much? 3. So nitrogen say we cannot say the bond because I need to give 3, but you need only 1. So we cannot make the compromise. So then hydrogen will say, so this is the chance. How can I leave it? So then hydrogen say, okay, your 3 electron you need to sell. So I have to arrange 2 more. My own caste are there. They will come to make the share with you. So then this hydrogen will call another hydrogen. Then another hydrogen will come here. So one more bond is there. So nitrogen say, still then 1 more I need because 1, 2, 3, 4, 5, 6, 7. One more is required for nitrogen to make it 8. So again this hydrogen will call another hydrogen to come with. So now another hydrogen will come and make the bond. Let us see. Nitrogen, how many electron altogether getting? 1, 2, 3, 4, 5, 6, 7, 8. Now nitrogen is happy. Now hydrogen, this hydrogen is okay. I am getting 2 electron. So this hydrogen okay. I am getting 2 electron. This hydrogen is okay. So I am getting 2 electrons. So what happened? This hydrogen will make its boundary. This hydrogen make its boundary. This hydrogen will make its boundary. So 3 hydrogen are coming to share the electron with 1 nitrogen. So now this hydrogen 2, this hydrogen has 2, this hydrogen has, they are making bond, they are satisfied. Now nitrogen will make the boundary line with its shared paired electron with the hydrogen. So now nitrogen will say that I have 1, 2, 3, 4, 5, 6, 7, 8. Now this nitrogen is happy. So it will smile now. Yeah, it is smiling now. Hydrogen is smiling now. Hydrogen is smiling now. Hydrogen is smiling now. Now 3 hydrogen are smiling, making the relationship, and 1 nitrogen is also smiling, making the relationship. So now the bond will be formed in this way. Nitrogen, 1 hydrogen is here, 1 hydrogen will be here, 1 hydrogen will be here. Like that they will make the bond. So now it will be written as, how many nitrogen are there? 1 nitrogen. How many hydrogen are? 3 hydrogen. So NH3. This NH3 is known as the heteroatomic molecule, because here nitrogen and hydrogen different elements are there. So heteroatomic molecule, that is called the ammonia. So in that way I have shown you the how ammonia is formed. Okay. Another example we will take how the methane molecule is formed. Methane molecule. Methane molecule is one hydrocarbon molecule because it contains carbon and hydrogen. The methane molecule, methane molecule formula is equal to CH4. Here I have given the structure. Methane molecule, atomic number of carbon is 6 because we need C and H. So atomic number of carbon 6, 2, 4, valence is 4. Atomic number of hydrogen is equal to 1, valence is 1. Here different valency, still then they can make the bond. How? Now let's see. Here 1 carbon is there. Suppose carbon I am taking. Its outermost electron is 4 electron. Outermost electron 4 electron. So now it has 4 electron. Now it will try to make how many electron? 4 more electron by sharing. I have told you carbon always make the sharing. So now it will now just ask the hydrogen. Hydrogen is coming here and hydrogen will share here. So now they are making the bond. But 1, 2, 3, 4, 5. Carbon is not satisfied. Hydrogen is satisfied. That is making the bond. Hydrogen is satisfied. So carbon will say, no, I have more, how much? 1, 2, 3, 4, 5. I need another 3. So this hydrogen will call another hydrogen to here. So this hydrogen is coming here with its 1 electron. Now the bond will be formed. Now this hydrogen is very happy. So now carbon said that I have 1, 2, 3, 4, 5, 6. I need again more, 2. So this hydrogen will call another hydrogen with 1 electron. So now this hydrogen will make the bond with this, with the 1 bond. Then carbon calculate that 1, 2, 3, 4, 5, 6, 7. 1 is shortage. So again this hydrogen will ask another hydrogen to come here and the bond is made. And now this hydrogen also happy. All the hydrogens are happy, very much happy. You see, smiling. All are smiling. All are smiling. All are smiling. Hydrogen. Let us see, carbon is smiling or not. Yeah, carbon calculate now. 1, 2, 3, 4, 5, 6, 7, 8. Now carbon also get 8 electron by sharing. So carbon also very happy and smile very nice way. So you see, carbon is smiling also. So now carbon is satisfied. 4 hydrogen are satisfied, making their bond. So in this way, the structure will be like that. Here hydrogen, here hydrogen, here hydrogen, here also hydrogen. That can be written. How many carbon? 1 carbon. How many hydrogen? 4 hydrogen. So CH4. This is called the methane molecule. In this way, methane molecule, which is a covalent compound, covalent molecule formed. So this is the process by which covalent bonds are formed, covalent molecules are formed. We discussed the covalent molecule like hydrogen.